Hello and welcome to my tutorial channel, Research with Dr. Okolie. Today, I would like to address normality tests in SPSS. Checking whether your data are normally distributed. In this tutorial, I'm going to demonstrate how you can use Likert Scale Data set to check normality assumptions. If you want to conduct parametric statistical tests or analysis. So if you want to check any of these parametric tests, example regression analysis, analysis of variance, ANOVA test, Pearson correlation, F test, and T test, you need to ensure that your data are normally distributed. But the case here is that it has to be approximately, not necessarily that it has to be purely normally distributed, but at least it has to meet the assumptions approximately normally distributed. And I'll tell you why it is approximately. Because there are ranges that you need to make, the ranges that you need to show for you to confirm that the data are normally approximately normally distributed. So in course of this tutorial, you will get to know this. I encourage you to sit back and follow this tutorial to the end. That is something that you need to know, and I'll prove a point for you. So here are some examples of normality test results. So if you look at the left side with the red bell shape, you will see that that is not normally distributed. You can see the histogram chart. You can see the histogram as some of the charts falling outside the bell shape. Now look at the right side, normally distributed. You can see the blue bell shape, which is looking pretty good visually. So this is how it look like if you made the assumption that your data are normally distributed. So this is exactly the right side. Your data will look like the bell shape presented by the right side. If your data are not normally distributed, your output will likely look like the bell shape and the histogram presented by the left side. Meeting normality test assumptions. So there are 4 ways to look at to check normality test assumptions, and I feel that I've listened to a couple of videos on YouTube, and I've read some papers published by some authors, and I think that is something that I need to draw your attention to. I think that is something that some researchers are not getting clearly about meeting assumptions of normality tests, particularly in the area of the skewness and kurtosis. So, but in this video, I hope to clarify that error. So the 4 ways you can check the normality assumptions are: the both visual and test analysis output must be investigated, so you need to investigate them. 2, the skewness and kurtosis tests using z-value has to be -1, between -1.96 to +1.96. If the results are not within this range, then your data are not normally distributed and you do not proceed with any of the parametric statistical tests. The 3rd one is the Shapiro-Wilk test. The Shapiro-Wilk test says that your p-value will have to be greater than 0.05. Okay, 0.05. If the p-value is less than 0.05, your data are not normally distributed. It's an indication that they are not normally distributed. Then, lastly, you need to look at the histogram and the normal QQ plots. You need to look at them visually to show that data are approximately normally distributed. And I've made available two references that you can look at. You may read these papers or read the book by Shapiro and Wilk, 1965, to get more information on how to conduct normality tests. Now, lastly, I'm going to take you to SPSS and demonstrate to you how to check normality tests using Likert Scale Data set. So let's head to SPSS. So this is a data set in SPSS that I have, and so I have two variables here which I want to check, I want to test, and the two variables have 10 item statements for Likert scale. So this is a typical Likert scale data set, so you can see this. Now I want to know whether the responses provided by the respondents are normally distributed. So to do this, I need to check separately. So you can see these are item statements 1 to 6 measuring adaptability. These are item statements 1 to 5 measuring career success. So the first thing we need to do is to head over to Analyze, Descriptive Statistics, Explore. And so we select all the item statements measuring adaptability, that is adaptability 1 to 6, and put into dependent list. So we select the histogram, uncheck this, and check normality plot with tests. You click OK, and then you click OK, and wait for SPSS to produce the data set for you, the results of the data set. So these are the results, and this is like the descriptive statistics showing the number of respondents, that is 200 respondents. So you can see there are total 200 respondents. So here you can see this is the item statement number 1, which is adaptability number 1, adaptability number 2, item statement number 3, item statement number 4, and item statement number 5, and that of 6. Now, what you need to look at here are the skewness and kurtosis values. You need to look at the skewness and kurtosis values. And if you go back to my explanation here, you can see that the values are between minus 1.96 to plus 1.96. The error that a lot of people, the trap and the error that a lot of people commit with their data scale, their Likert scale data, is that if you look at the skewness and kurtosis here, you will see that this is, if you look at this, is the statistics for skewness. If you go back here, you will see that it is falling within this negative 1.96. Look at this. This is negative 1.04. Okay, 0.45. So which is within the requirement of skewness and kurtosis. So you can see the kurtosis also within the threshold. But if you go down to all of them, you can see, let me show you this. Number 2, you can see the skewness and kurtosis looking good. See that? Skewness, kurtosis. You can see here skewness, kurtosis is skewness here, kurtosis. You can see all of them are falling within the threshold. But look at the normality test of Shapiro-Wilk and Kolmogorov-Smirnov test. You can see that the significant values are all statistically significant. You can see that. So you can see the Shapiro-Wilk test, that if the p-value is above 0.05, then your data are normally distributed. But when the p-value is less than 0.0 significant, that is when p is less than, then you do not have a normally distributed data. So this is what this analysis is actually showing us. But when you look at the skewness, you can see when you look at the skewness and kurtosis, they are falling. Look at the point I'm trying to make. When you look at the skewness here, okay, look at the skewness and the kurtosis values here, you can see that they are falling within this range. So some people will, a lot of researchers will just look at it and say, oh yes, the data is normally distributed, but even though that the normality test is not meeting the assumption, it does not, the spiral weak test is not meeting the assumption, the skewness and kurtosis are meeting the assumption. The truth is that they are getting confused. So let me tell you what to do to confirm that even though that the skewness and kurtosis values are within this range here, that the data are not normally distributed, because the normality test of normality by Spirowick and Komogrove-Shminov test confirm that the data are not normally distributed. So I'm going to open the calculator and then take it to this side. So this is the first item statement, that we have, and the skewness is minus 1.045. Oh, sorry, excuse me. Minus 1.045 divided by the value of the standard error. If you divide this by the value of the standard error, you will find the actual value for skewness. Now, what do? I divide it by 0.172 equal. So you can see that we have minus 6.08. Okay, so to calculate the value of the kurtosis again, what we need to do is to divide this kurtosis by the standard error of the kurtosis. So what do we do? Okay, so to do that, we said minus 0.139 divided by 3.42. So you can see, to check the kurtosis here, you can see that we have negative 0.139 divided by 0.342. So you can see that we have negative 0.46. Call up the calculator. So this is negative 0.821 divided by negative 0.821 divided by 0.172 divided by 0.172. Okay, so you can see that the skewness here is negative 4.77. all right, so this is how you can use the value of the z-test by dividing the value of the skewness and kurtosis by its standard error. So to do this, I said divide the values of the skewness and kurtosis by their standard error values to get the real results. So we can see that from the analysis, from the results of the analysis, that these values are not showing evidence of normal distribution of the data set. To confirm that this is not normally distributed is to run another test by using the variable itself after computing it. Okay, you can just go to transform and then compute the variable. You can just compute this variable. So I can say adaptability real. Okay, and then I will come to here, go to statistical, and I will take the mean, drop the mean here, and group the Likert scale data set. So I can group this and put comma, this again, comma, this again, comma, put comma, this and comma, and then lastly put this. Okay, and then click OK to generate the variable that is the adaptability. So this is the variable here. SPSS has created the variable for us, so which is adaptability real. So we can now check, go to analyze to check using this particular continuous variable now at this point. So I can knock these out, and then insert this and check. So let us see. So this is the continuous variable. Now this is the normal variable itself. So you can see, I also want to prove this point. So you can see now that this is the case processing, and this is the descriptive statistic for the continuous variable measuring of the adaptability variable itself. Now let us pull out the calculator this time around and then check the skewness and kurtosis values. So for the skewness, let us see negative 0.586 divided by 0.172. So that will give us, you see, so this is giving us negative 3.41. So let's head back here so you can see, look at this, this is above this value. Okay, it's not within this value. So let us also go back to the SPSS once more and then look at the Spirowick test. You can see it's statistically significant, showing that this data is not normally distributed. So let us look at the QQ plot. So look at the QQ plot. So the QQ plot will show you that you can see how the data is dancing. The data is dancing around the line. So if the data are normally distributed, these dotted plots here will wrap around this linear line here. Okay, so but again, let us look at the histogram chart. So looking at the histogram chart shows you that this is completely the data here, the data set are not normally distributed. So you can see the bell shape. So let's head over to the previous result that we have. So you can see this is not normally distributed, then this is normally distributed. So this is how you can confirm that your data sets are either normally distributed or not. It is not to simply base your findings on by looking at the values of the individual values of the statistics of the base your findings from the actual skewness and kurtosis. You need to divide the values by the values of the standard error. So that will enable you to know whether your data are normally distributed or not. So if your data are not normally distributed, then you do not need to test any of these analysis. It means you're not meeting the assumptions. So you can now test non-parametric tests. You can do other non-parametric tests. So thank you so much. This is how you can confirm that your data are normally distributed or not. The z-value will help you to confirm, that is, dividing the value of the skewness by the standard error and the value of the kurtosis by the standard error. So that will give you the actual values if you really want to if you want to base your findings on this. But I think this is this will really strengthen your data set and then be able to build trust in your parametric test analysis. So in another video, the next video, I'm going to show you a typical example of a data that normally distributed. Thank you for watching. If you find this video interesting, please share and like, and then subscribe to the channel so you get notification when I post a new video. And then I'd like to get your comments on how you have managed data that were not normally distributed. So I'd like to learn from you. Let's keep the comments coming. Thank you so much.